Recording. Hello, everyone. Thank you so much for joining us today for the AIAA Los Angeles Las Vegas section town hall meeting. Today we have a wonderful speaker. He's going to share his experience on very exciting topic about this, digital transformation and the digital frontier, which is a very big movement right now in aerospace. So before that, we have some logistics. First of all, there are coffee, hot water, and refreshment in the kitchen and bottled water. So please grab something. This is only for in person here. For online folks, very sorry. We are trying to help you to come here and enjoy, have fun with us. Next time, please come here, join us. Um, okay, so of course, online folks are highly welcome. So Zoom, please, you are welcome to click raise hand um, on Zoom and or type something in the chat to speak out. It's better you speak out and interact with the speaker. It's much more fun that way. Of course, if you might have some problem, you are welcome to type in Q&A. We'll bring it up to the attention of the speaker. So the next thing is the restroom is outside the entrance of this meeting room, and you have to wave hand to the librarian at the front desk. They can unlock the door for you. uh, the other thing is, of course, we highly appreciate the Longdale Library. You see, this is wonderful, beautiful meeting room. That's amazing. We really appreciate the librarians, their help. Um, the other thing, of course, we appreciate AIAA. As you can see, AIAA stands for American Institute of Aeronautics and Astronautics. So means space and aviation. Sorry, I have to say this again because some people didn't understand what AIAA came from. So basically, AIAA came from a merger in 1963 from the two prior organization with the history trace back to 1920s. One was associated with the Wright brothers on aviation. The other one was associated with Robert Gardner on rocketry. It's called American Rocket Society. So both societies, they voted to join AIAA in 1963. So literally, we have almost 100 years, of history. But being said so, we have been doing a lot of things. Earlier, we hear from the speaker and attendee discussing certain things that like a digital transformation has been in the industry for a long time. So AIAA has been doing a lot of things that was actually leading the organization, I mean the industry. But we are not a company, we are not a university, we are a professional nonprofit organization. We have many members working like our speaker today, working all the industry, either you're individual or working in a major aerospace company, NASA, or you're teaching university, high school, or you are school student membership, you're professional. So this is what AIAA really is. And we have national, very reputable publication journals. That's very serious, technical journals. We also have Aerospace America. If you join, it's free for all members. And we regularly hold conferences, forum in national level. And we are the local chapter. We support our national headquarters, but we also have our local activity like you are here right now. So next year, the next upcoming AIAA National Forum is SATC, which is Orlando, Florida. The next one, I think, is something between, but there's a very big thing I also want to talk to the speaker. Maybe you can consider speaking there. Is we are going to have the AIAA Ascent, which is more space related in Las Vegas, again in Caesar Forum. I just came back from there last week. But next year, what's different is they are going to combine with AIAA Aviation to become one conference. So you have aviation people and the space people. So you have more audience, it's more fun. And the AIAA also have a forum called Defense. It's more about defense, those kind of things, advanced technology or something like that. So basically, it's a leading nonprofit professional organization. So it's welcome. If you're not a member yet, please consider join us. If you're a member before, this is a good time for you to come back to the big family. So Our speaker today, Mr. Dennis Liang, he formerly was with Northrop Grumman, involved in satellite management, operation, manufacturing, and he's now his own company, Daibashi Consulting. He's the founder, the owner, and he a few more years way back, long time ago, he was expert in Dryden, now Armstrong Research Center, doing hypersonic research, hypersonic vehicles. So this, enjoy a lot of talk. Today we have a meeting room reserved till 2. And the talk will probably last for 1 hour and the Q&A, but you are welcome to stay here with the speaker and networking. And if you need any serious food, lunch, there's Corner Burger just across the street, within 30-second, 1-minute walk. If you're really, really hungry, then the refreshment is not enough for you. You can try that. So, okay, without further ado, let's welcome Mr. Dennis Liang. Thank you.
Thank you, Ken. I appreciate it. Thank you, everybody. Everybody probably knows who I am by now, based on all the talks that I've been doing. But like Ken said, I've spent a good portion of my years at Northrop Grumman in the space industry. What I'm going to talk about today for digital transformation is not necessarily concentrated in the aerospace and defense industry. It's something that can be utilized across a lot of different industries, such as the medical, retail, other kind of manufacturing world. So look at this from a large scale perspective that you can apply this to every other kind of industry. A lot of the things that I talk about here in these presentations is not reinventing the wheel if it's not necessary. There are other things that other people have done or things that we have done in the aerospace world that can be applied to other industries. So keep that in mind when we go through this. So when we talk about digital transformation, digital's not working with me right now. Okay, there we go. So when we talk about digital transformation, it's kind of the new buzzword just recently, but it really is using different kind of technologies that's available to us and really utilizing that in our everyday lives, whether it's at home or whether it's at work, and how it can make us more efficient, how it can give us more data so that we can be more efficient and innovative, right? And how we deal with our customers. But if you really look about digital transformation timeline, it's been around for a long, long time. Like I said, it's just the newest kind of buzzword that we look at. Whenever the microchips started, electronics started, that was really the beginning of our digital transformation. You'll see kind of big milestones along the way during our transformation when personal computing came on. Mobile phones, laptops, all of those are kind of the big milestones that came out that kind of transformed how we utilize these kind of mobile technology, electronic technology in our everyday lives. If you really think about, most of us can go back far enough to experience some of these major milestones. When iPhones came out, it transformed how we did things, right? We don't even look at our laptops anymore. Most of the stuff we do is on our iPhones, right? Smaller, faster, more powerful, allows us to be mobile, to do more things along the way. One of the stories we did is a couple of years ago when we were doing digital signage, we worked with that company to be able to provide real-time information and status onto our executives' iPhones so that when they're at the airport, they can get digital information of how their organization is doing without having to call a meeting, right? So now they're just sitting there and they're just scrolling through versus having to call a meeting and we can hear them at the airport. So even simple things like that just recently is part of this digital transformation. But when we look at digital transformation, this chart probably says it all. Every couple of decades, you'll see exponential growth, right? Not just in usage, but exponential growth in companies that provide either a service or a particular piece of hardware. And it just is going to continue to explode and grow. Now, what we're going to talk about a little bit later is how do all of these combine together, right? Because based on everything that's happening, one person or a couple of handful of people is not able to manage all the data that's coming through. And you'll see that in the aviation world, you'll see that in the medical world, that the inundation of data that you see, there's terabytes of data behind, constantly flowing through. And who's managing all that data? A person? No, it's these new computer systems. If you go to some of these trade shows now, you'll see a lot of these companies. Actually, I just came back from SEMA, and you'll see, I saw a lot of these software companies now. They're putting out their manufacturing or operations system optimization software. And that's taking all their data to provide something that you can look at very quick and easy and be along your way, versus having to sit there and decipher the data from all these different kind of sensors that you usually get. So just remember, all of this is great by itself, but it'll be better if it's all combined together. We're going to explore four main parts in this meeting. It's going to be space exploration, manufacturing maintenance, machine learning, and our final favorite one is cybersecurity. That's also one of our more recent buzzwords, is cybersecurity here. So let's take space exploration and robotics. It's a given in space that we're going to have a lot more digital systems, software, hardware to manage this. Because we look at it in a high-tech world, so okay, very easy to accept that in the space world, we will need this digital revolution. Manufacturing is a bit of a mixed bag. It's going to be a half and half. Certain companies will be open to digital transformation because they realize they need it in order to continue with their optimization and increase their ROI from a financial standpoint. There are other companies who think they're fine and moving along and they don't need it. So this one's a bit of a mixed bag, but this digital transformation in a manufacturing and maintenance world is going to be revolutionary. A lot of the things that we currently do right now is manual. And you'll see that as we continue on. Did you change something?
Focus.
No, I just moved the, there's a warning.
Oh, hold on. There we go. Oh, there we go. Okay. And then we're going to talk about AI and machine learning. Probably over the last 2 decades or so, since there's so many companies that's coming out with all of these electronic systems to help us in our everyday lives, iPhones, Amazon Alexas, Ring doorbells, you know, all these kind of systems. But you don't have a overarching system to help manage it. There's so much data going on that a single person would just get inundated. There's too much data for them to manage and to manage effectively, right? And so the big system right now is AI machine learning. And of course, cybersecurity, when you do all of these other systems, you're going to have to maintain your data. You're going to have to keep it secure. There's a number of different ways of looking at cybersecurity. One way of looking at cybersecurity is somebody trying to break in to your server and trying to get the data or manipulate the data. There's another part of cybersecurity, which I won't really talk about too much here, is making sure that AI doesn't take or mimic some of your proprietary artwork, songs, or data in itself. So there's different kinds of cybersecurity, but we're really going to concentrate this time more on people trying to break into your physical servers to try to steal the data. So let's look at space, for example. And this is just really a top view of a integrated system control. Let's talk about the civilian air traffic controlling system. When you go to the airport and you look at your information of where your flight is, what the gate is, and so on and so forth, there's a lot of information behind it that you don't see, right? Such as the baggage handlers, the food service people, the gate agents, all this data behind is being managed by one overarching system. So when you look at space travel, let's think about it. I'm not even talking about what's in near Earth orbit, okay? I'm talking about beyond near Earth and all the information that's you're going to be needed. You have spacecraft going back and forth whenever we have a permanent base on the moon, whether it's cargo, whether it's passenger or whatnot. You're going to need new satellite systems for GPS and communications around the moon. You're going to have a space station that circles kind of midway, like a gateway station. They're going to have a lot of information going on, communications, GPS, a lot of data going back and forth. So it's a given that in space, you don't have the opportunity to just put more people there to do the work, right? Because of the conditions, because of the environment, it's just not something that right now is feasible to do. So what do? We need software systems. We need a top-level integrated control to help us along. They may not make all the decisions, but they're going to be there to help give us solutions so that we don't spend the time trying to figure all that out. Because a lot of things that can happen up here, split second, right? You can't wait a couple hours to figure out what the solution is if you have an emergency. You're going to need something to spit something out with at least an 80% confidence of the solution and then go from there, right? If you don't want the system to make the decision for you, you're going to have a hybrid system. And then, of course, everything that goes on, on the moon, whether it's transportation, mining, habitats, even robotic systems that are on there, they all have to work together. There's a lot of data that's being transferred together. So you have data there on the moon, you have data up here, you have data in near orbit of Earth, and then you have data from the Earth. So all this data is going back and forth all over the place, point to point to point to point, right? And so you're going to have to look at, can one person handle all that? Can 2 people handle? Can 100 people handle the kind of information that's going through there? Probably not. So we're going to need to have some kind of system developed for this kind of new space travel, just like we did when aviation was started, right? When it first started, you didn't have any of these systems around. But as the technology got better, you had GPS, you had computer systems, all of that necessitated the need for a computer system to help you along. And now you have autopilots that can do most of the flying, right? It can actually do the landing and takeoff if you allow it, I believe, right?
Yeah.
So now it can theoretically fly itself from beginning to end if we wanted it to. And that's probably something that we're going to have to come up with here as an opportunity from a space exploration or robotics standpoint. So let's look at what happens on the moon as an example. What I put up here, you can see this is just some of the data that I can fit onto this slide here, right? You look at what happens inside your habitat, environmental, water and waste, emergency system, life support system, fuel and storage, radiation, shielding, impact detection, communications, resource, medical data, so on and so forth. It just keeps on going. Some people might ask, well, is it necessary to have all this? I go, yes and no. Let's just take impact detection, for example. Right now, if something hits your house, you just walk outside and see what's going on. You probably don't want to do that here. It's probably going to take you an hour to get suited up to go outside just to look for it and come back in and back and forth. It's just not efficient for you to do that. And so that's why you have all these additional kind of sensors. But we also have to look at maybe the daily work schedule, especially if you have robotic systems, right? Are you going to program these robots to say, okay, you're going to do this on a daily maintenance? If you run into a situation, can you solve it yourself? Or do I have to be in a controlling station to kind of telework with you and control the robot to make sure it completes its task? So depending on what you come up with, you're going to need some kind of like a management overall arching system as well. And there's going to be a whole set of data in that system, like project management, daily scheduling, command and control for lunar operations, geological data, if you're growing food, greenhouse data, solar radiation, pressure, oxygen composition, humidity, emergency systems, growth parameters, right? Pest control, scientific research, the data just keeps coming. Power levels here, right? Power levels, what's the status of my hardware? How do I optimize the positioning of it, right? Power delivery and usage. I mean, are you guys getting inundated right now with all of this? And you can imagine this is just first level of data that's coming out to us, right? The astronauts in their suits, pressure and temperature, air quality, humidity, light intensity, emergency systems, so on and so forth, right? Mechanical systems from all of the equipment that you have. How's my mechanical status doing? Radiation shielding, GPS location, communication, resource utilization, medical data telemetry, command and control. And this is not even including if you have scientific operations, mining operations, or construction operations going on. You're probably going to need an entire marching army if you do not have a top-level system integrated control to manage all of this for you, right? If you think you're going to put more people in here, then the system grows, then the data grows, right? They all link together. So the more people you put in there, the more data is going to have, and then you're going to be right back at the same problem. How do I get more people up there? Or do I have a automated system to either manage it automatically, or a hybrid system to help a person so that they're able to manage more systems by themselves versus having more people there? So let's look at manufacturing and the maintenance side. This could be both either on the moon or in orbit or here on Earth. One of the big things that we've been talking about lately is smart factories. I built a smart factory for Northrop, one of my last projects before leaving there. And we realized that the way we've been doing things over the years, although it worked, it wasn't very efficient, right? And efficiency isn't necessarily measured in financial dollars. Efficiency can be measured in extraneous work where your people get burnt out, right? Extra moves from building to building that adds risk to your hardware and to your people that isn't necessary, right? So there's additional things that come into play when you talk about smart factories. And when you have a smart factory, now you put in data, you put in sensors, you put in equipment, you upgrade things, it becomes easier. You look at your house, a smart house versus a regular house. Regular house, you have to go find the information. A smart house, you can walk by, talk to your Alexa, talk to whatever system you have, and it tells you the information there, and then you continue on your day, or check on your phone, right? Continue on. Nowadays, you forgot to close your garage door, right? Go on your phone, log in, close it yourself. Before, loop around the neighborhood, come back and close it yourself, right? So you kind of have to look at which way you want to go. But you can't have a smart factory without some sort of automation and robotic systems. We can always put more people on there, but again, that doesn't necessarily solve the problem, because automation and robotics is sometimes suited way better for the conditions of your work, especially if it's hazardous, repetitive, high volume, then you want to use these kind of robotics and automation systems. But these automation systems isn't necessarily just the hardware itself, but it's the software, how you manage it, right? How do you control these robotic systems? How do you input the work schedule to these robotic systems? How does it tell you its status, whether it's working, something is wrong? You got to manage all this stuff, right? And so when we add in automation or robotics, we have to figure out how we integrate that to our overall factory in itself. You can't just say, I'm going to put in some automation and it's going to run by itself. Well, what happens is that automation, that robotic system becomes a standalone system that another person will have to manage, right? And so that system now becomes just part of the cog in a whole wheel versus helping to solve the overall issue. And this is where we get to the Internet of Things. This was, another buzzword a couple of years ago. What does Internet of Things mean? It's essentially sensors everywhere that provides data to you, right? That's your Ring doorbell, that's your Amazon Alexa, that's your Wi-Fi enabled garage door opener, right? All these kind of things that's connected. Your smart fridge that can tell you now whether or not you need to buy eggs for today because you're out, right? This is all these sensors and all this information that you can place on the factory floor to help you figure out some of these things. Some companies will ask, why do we need it? Well, why do you need it? Because then you don't have to hire a person to do it, right? Because these are really small, these could be very, very small tasks that isn't necessary. We used to hire engineers to do PowerPoint slides for some of our executives. I'll let you think about that for a second. No engineer went to school to do PowerPoint slides, right? And so this is what you're going to be doing if you don't have some of these sensors to kind of help you out. And now, if you look at AI, there's software out there where you plug in what you want and it'll crank out a PowerPoint slide for you, right? No need for that job anymore. Now that engineer can go to what they really were meant to do, research, development, and do their engineering work. So digital twins. I know some people here really love digital twins, so we're going to talk about digital twins. There's multiple ways to look at digital twins. Digital twins was probably one of the big buzzwords that came out when NGAD was released. For those who aren't familiar, that's the Next Generation Air Dominance Fighter. And if you read up about NGAD, NGAD was developed in 2 years, right? A brand new 6th generation fighter, 2 years. And that's generally a 2-decade operation. But because other countries are rapidly catching up, and the United States and the aerospace defense field realize that they no longer have a monopoly to spend 20 years to develop something, they've got to be faster. And so what do? Okay, we need to be able to be faster. Well, what does that mean? That means a digital twin. So digital twin, let's just take from an aerospace perspective, essentially, it's a twin that you can do all your testing in, you can do all your design in, you can do all of your scenarios in without actually having to build a piece of hardware, right? You test everything that you possibly could test on this, and then you build your hardware, and then you're ready to go, okay? In the space world, we don't necessarily have a quote unquote real digital twin. We have what we call a hybrid twin, where we have what we call test set. We have our all these test sets, and it mimics essentially the real flight hardware. So we have the boxes, we have all the hardware, we have everything laid out on the table, all the electronics as though it's the real spacecraft electronics. Every cable, every harness is the exact same length. So when we do troubleshooting, we do testing, we do software testing, everything is done on that hardware twin so that we do not touch the flight hardware. We don't potentially damage it in any sort of way where we're versed electrically and or mechanically. So there are different ways to do kind of digital twinning. You can also look at digital twin from this perspective. We do a lot of things called trailblazing. And trailblazing is essentially, if you've never done the operation before, we send out an entire team and we map the whole route, wherever the satellite is going to go to get delivered. So we have to understand whether it's going on a plane, whether it's going on a truck, or whether it's going on the boat. And so what we do for some of these trailblazers is we fly a C5 out to LAX. We put an empty container in so that we can try it out, see the fit checks and any kind of issues that we have. And then we take the container back and the plane flies off. That's $1 million a flight, round trip for a C5, just to fit check something, right? From this perspective, you have the entire CAD drawing of an airplane. You have exact dimensions down to the millimeter, unless they modified it. But from a military aircraft, you know everything that happens on it. We have the design of the container itself. So why can't you put it in a AR/VR system where you essentially digitize all of that, and then you can try it out multiple times to be sure and confident that when it comes down for real, that it's really going to fit. Okay, there's different ways of looking at the digital twin system. So we can spend all day on digital twins, but we're going to move on a little bit here. Supply chain digitization is one of the big things, especially during the pandemic and all the backups and everything that's been happening in our supply chain world. But supply chain surprisingly is very manual, especially in aerospace, the medical world. The only one that has probably been very good at this is high volume. So you're talking about Amazon, you're talking about the Walmarts of the world, where every minute counts to them. They're flowing so much goods through that they don't have time to wait for 10 seconds. It's got to be going. And so they try to really digitize their system. They really have their warehouses connected. They have RFID readers at the door, so nobody's there with a scanner to scan a pallet that comes in. It just goes. As soon as it passes the sensor, they know how many, they know what it is that went into what truck, and it just goes. They just keep loading. All that information gets uploaded into the system, into our overall supply chain management hardware system. And we need to do something similar to that to other industries, because in the aerospace world, I'll give you an example right now, is if I were to go place an order for a hardware or a piece of consumable, I know I need it for 6 months, in 6 months. So I try to do 6 months plus 3 weeks. What most people don't realize is you go to the next organization, if somebody has to approve it, well, in their organization, they have 2 weeks to approve it. Once they approve it, then it goes to the buyer. Well, the buyer has 2 weeks to send it out and get bids. So that's another 2 weeks. Within those 2 weeks, you have 3 weeks to wait for the bids to come in. And after those 3 weeks, you have another 2 weeks, right, to finalize who wins the bid and send in the order. And then you have the lead time. So what happens now? You're way beyond your 6 months. You're never going to get it in time, right? And so there's a lot of these systems that just is very manual oriented. There's many different roadblocks, all stopping this efficient system along the way. So we have to find a better way to manage our logistics system. When you connect these kind of logistics systems with your project management and your other kind of sensors, now you get a better picture of what's going on. So there are software systems out there that manage your project management flow, but it's just as good as the person putting in the data. That's all it is. It's not connected to anything. It's all a matter of, if you had a good project manager in there that knows all of these kind of hurdles that you go to, they're going to tell their people, you have 6 months, order it a year ahead of time, right? But the problem, some of the problems with that is if you order it a year ahead of time, you might have a shelf life with that consumable, so you can't use it early. So there's a lot of things in there that if the project manager didn't know, you would run into problems a little bit later. So cloud computing is probably one of those that was recent as well. This was very transformative to small businesses. So they didn't have to do it manually. They didn't have to hire their own people to do this kind of work. So you take like Amazon Web Services, is probably one of the top ones at the time for cloud computing, is they provide all these services for them. Hey, we can manage this. We can give you statistics. We can do all these kind of things for you. You just pay us every month, and you don't have to worry about hiring somebody. And what you have is you have the Amazon behemoth and all the engineers and all the people behind you to help you. Right? Part of the cloud computing. Cloud computing does not necessarily work as fast in the aerospace world because they're a little bit more sensitive, because a lot of it's classified. A lot of this is in proprietary, or you work in a classified world. So getting them to accept cloud computing was a little bit hard, but we did make inroads at Northrop. They were willing to hear us out, at least on this, because what's happening is that our customer, the government, realized that, hey, we cannot keep paying you an infinite amount of money, right? So you guys have to find out easier ways to manage your data and to make sure that it's secure. So you stand up your whole new cybersecurity team, and that's a company to do a trade-off, right? Is it worth for them to do it themselves, or should they offload it to somebody else? Oops. Sorry. Wrong way. And with all of this, big data analytics. There's so much data out there, and I guarantee you we probably don't even look at half of it. Okay. You have to be smart about how you utilize your data and what you use it for. In my old job, there used to be just tons of data, engineering data, facilities data, customer data. It's just all over the place. Everybody used to tell me, yes, it's in our server, it's digital, we're good. Go. You can't find it, it's not good. It doesn't matter whether it's on paper or whether it's in a network buried beneath 300 different files. It makes no difference to me if I can't pull it out quickly, right, and get the data that I need and move on. And so one of the examples that I used for my team when we moved, when we're building this factory was back to the airport again, right? When you walk into the airport, you look at one screen meant for the passengers, and it gives you a few sets of the information that you need. Gate, time, plane, location, where it's going, and so on and so forth. That's all you need, but there's terabytes of data behind it that they don't need, the passenger doesn't need. And so how do you filter that out easily for that one particular person? So when we were building this factory, we put in all these signs and we made use cases for, okay, this station needs this kind of data. Parse that out, give it to them. The technicians on the floor use this kind of data. Parse that out, give it to them. Engineers need this, so on and so forth. The managers need status, so let's give them status based on all this information, right? And so one of our use cases here was every single morning, we used to pull in all of our managers, highly paid managers, and all of their leads, and we'll sit in a meeting for 45 minutes to an hour, and we'll go down the line. What's your status? How did you do? Good, 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 bad, good, okay. So what you did is you probably wasted half the people's time in that status meeting because they were good. So we were working to put in a system where we're working this digital signage company where the manager or program manager would have a screen in their room, in their office. They walk in and they see all their managers, which one's green, which one's yellow, which one's red, plus Y. So now all he needs to do or she needs to do is go to that person and call that person up, what's going on, versus having to go ask everybody else and wasting their time. I've sat in so many meetings at 6:30 or 7 in the morning, kind of dozing off because it's not my turn yet, right? And so we're wasting time, right? Every minute counts because we're a business, right? Minutes may not look like a lot, but when you add up minutes from your group of managers who make a certain amount of money, and then you parse it out throughout the division of Southern California of 9,000 people, and you parse it out to Northrop in general of tens of thousands or more, you add it up every single year. We're using tens of millions of dollars for people to sit around and wait. So your turn to say something. I'm good, no issue. That's what you waited for. And that's what we're utilizing. So be smart about how we use our big data. Now, sustainability is one of those things that I know a lot of companies now are trying to get into because it's a mandate. There's a lot of rules going on right now. But it's actually a very easy thing when you have a lot of data going on, is now you realize, oh, well, maybe I don't need to turn on all these lights on, right? Machinery doesn't need to be used at this time, and so on and so forth. And so you become a little bit smarter about how your usage comes and your kind of waste. So you start to realize, oh, well, I got data. Wow, I didn't realize that we were, wasting this much energy, or we're consuming, so much product, and so on and so forth. Why do we need to do it? From a sustainability standpoint, I give an example, and it's part of the part of the sustainability, but it's also part of the supply chain. I used to have part of the supply chain under my directorate, and what happened was you would have multiple labs, and each of those labs report to a different organization. And those organizations are not tiered into each other. So what happens is each organization may use the same kind of consumable. Let's just say this consumable is a particular type of adhesive. Some of the adhesives we use are $5,000 to $8,000 a quart. Okay, I mean an ounce. Sorry, an ounce. So these are some very, very expensive stuff. So what do? They go out and then they buy their own because they don't talk to each other. But the problem is that there's a minimum buy. So in order to buy from this one vendor, that lab has to order, say, a quart worth of it. And this lab has to order a quart worth at a minimum because they won't sell it to you any other way. But what do they need? One syringe. So you probably needed $100 worth, and you trash the rest. Why? Because they don't talk to each other. So if you combine them all together and say, hey, all these labs actually use the same type of adhesive, then I can only, instead of buying 15 to 20 ounces, I only need 3, right? And that's just for one consumable. And because we don't talk to each other, and because nothing is interconnected, we don't know that. Unless you've worked in these areas, then you would know. But short of that, it's based on a person's knowledge. Okay? So like that, you don't have that knowledge, you wouldn't know it, and each person just continues and buys and buys and buys. And I like to tell this story too, because like my wife does some shopping, and she goes buy some stuff, and I come back from Costco. Why'd you buy all this stuff? I didn't know you were buying that, right? Exact same reason. We didn't communicate. We didn't know, right? And so now you have duplicates of all this stuff, and some of them might go to waste. But when you look at it from a manufacturing standpoint, you're talking in millions and millions of dollars, right? It becomes very, very expensive. All right, so let's talk about AI machine learning and how it can help us. There's been a lot of talk of, we have to be careful with AI and machine learning. And you know what? I agree with that, right? It can run off by itself, and we would be in a lot of trouble because you don't want it to make all the decisions, because it can make some decisions without external factors that are not inside of a sensor that they can read, right? Such as experience in something, right? That's not something that you can program in a sensor for an AI. For example, if you have a program manager and you're sitting there, and when you talk to the customer kind of says certain things, give you kind of red flags, and you know what's happening because you've dealt with that before, then you make your decision based on that. You wouldn't have that information here. So that's why there needs to be a hybrid system when you're talking about certain kind of decision-making abilities. Other things that you look at, such as, oh, you know what, tell me when this air conditioner is going to go out 3 months before, and then we'll deal with it. Something like that doesn't require really a facilities engineer full-time dedication to do that. And these what these sensors can do. So we have to be cognizant that these machines and AI learning machines can handle the big data. They can provide you the decision-making information faster than you can yourself. Okay? Even if you're the most experienced person, they have a larger data set that you don't. Let's take the medical world, for example. I want to say it's a couple of years ago where they did a test where a machine AI learning system diagnose diseases faster and better, with almost 90% accuracy as a doctor did, but much faster, at a fraction of the time. And why? Because that machine learning had all this information across the United States, across the world, that maybe that doctor did not have. Okay? And so when they did that, when that machine did that analysis, they had a lot more information. They came up with almost a 90% accuracy rate, right? Which is sometimes actually better than the doctors, depending on which doctor you have. And so that's why we have to look at, this real-time decision making, all this predictive analysis, and this adaptive and self-learning systems. Because the more information you put in there, the more scenarios you give it, the smarter it gets. I know the last couple of years, for those who follow Tesla and its full self-driving mode, that's exactly what it's doing, right? It's learning. It's learning from how you drive. It's learning from things that you do that it would not have done, right? So it's learning. You're teaching it. Some people don't realize this too, but if you remember, some of these websites that you go onto, from a security standpoint, it asks you, find the pictures with the stairs. Find the pictures with the light pole. What you're doing is you're training their AI for free. That's what you're doing. The machine is learning. The Google server machines are not, they're learning from you of how you figure this stuff out. So you're teaching these computers and you didn't even know it all these years, right? They're learning from you for free. And so this is where the automation and efficiency comes in, right? Where now it has an intelligence level of a certain part, and now it can do certain things that you're confident for it to do, right? Take Tesla, for example. People are confident on the freeway, straight freeway, let it drive. They're pretty confident. I know a lot of people, a lot of my friends have Teslas, but there's one thing that they keep telling me. If it's on the surface streets in a city, they're nervous. Okay, it's not quite there yet. But it's smart enough to drive in a straight line on a freeway, very little turns, very little interactions with other things, right? So it's learning, and that's where the automation efficiencies, start to come in. Once it does learn all that stuff, then it becomes more efficient, right? Same thing from an aircraft perspective, right? Automation and efficiency. Autopilot, right? Autopilot used to just be able, okay, once the pilot gets up, we can fly by itself, great, but we still have to land. But now the system's smart enough to be able to take off and land by itself. Right? And this is where enhanced safety and security comes in. This one does go both ways as well. There's security to make sure that AI doesn't go and do something you don't want it to do. And there's also security of the AI being able to find and fix things faster than you can, because it has more information coming in than you do. Right? Let's take, for example, your home automation. Everybody has WISE cameras, Arlo cameras, security cameras around your house. Right? So what this software system that it has is when it detects something or it detects a face versus a cat, right? It can make those distinguishing characteristics now, is that it will send you information so you can make a decision what you want to do. So imagine if it didn't do that. You have to log in every single time and watch 24/7 in order to find that piece of information that you might need to make a decision. You just wasted your time staring at a blank screen until something happens. Right? So some of these safety and security protocols are coming where the machine is fast enough to be able to detect and let you know what's happening. Scalability, pattern recognition, optimization, compliance, and risk management. All of these kind of go hand in hand with what we talked about before. The more mundane things that you offload to your AI or machine learning system, the more time you have to dedicate to the overall vision or strategy or something. Okay. For those who have kids, like, now that they're old enough, I make them do the laundry, I make them wash the dish. I'm trying to automate my house with them versus me having to do it myself. They're smart enough to figure it out now, right? So that's kind of my automation right now at this point. But Now I can scale what I do in the house because I got them to help me to do the mundane tasks, right? They start to recognize, oh, well, if the dishes have piled up above the sink line, I probably should do it before I get yelled at, right? They're starting to get smarter, and you can optimize what you're doing. And then compliance and risk management, right? Computer systems, again, you can use that as long as you program it correctly of rules that it needs to follow and the risks that it needs to watch out for, right? Two of the most biggest systems out there right now that's been around for a while is the smart home that we've been talking about. But there's also this battle management system for those who are very familiar with the aerospace and defense world. Is these battle management systems have been around for a long time in the military because they've realized that there's so much information from satellites, from AWACS, from drones, from ships, from people on the ground, from planes, that they have to be able to coordinate all this, right? They learned over the years that you don't get the right information, you might hit your own guys. So let's be smart about how we do this. And so they've been building these battle management systems. And what is this? This is essentially to take all the data from all the different assets that you have and manage it into coherent data that each system requires. They don't get everything, but hey, they will get something, these guys will get something. That's what the whole battle management system is. So let's look at what does the system level integrated control look like? You know, we have to use these kind of solutions to optimize our workload, optimize all of the small hardwares that we use. You know, the very first thing is these systems are going to handle the big data. Then what do we do with the big data? You take that big data and we start to recognize patterns. And we start to recognize all of these kind of things that we might not have seen because as a human, we're only human. We can only do so much. And that's based on our knowledge, and that's just based on you know, how interested we are in knowing about the system. But these machine learning systems are 24/7, constantly trained on, okay? And then what do you do after that? Well, you have a lot of things you can do, right? You can do predictive analysis, right? You can do self-learning, you can do automation efficiency, scale up, the things that we talked about before. Now you use all this data, you recognize what it is, and now you can make these decisions, right? Now you can do real-time decision making faster than you could have before. So with all of this data and all of these areas that we have, you have information coming from all of these sensors, you have information coming from people, you have information coming from email. What do we do with all this? Every single one is a potential point of entry. And we have to look at how do we secure those points of entry. As you saw on the second slide, third slide, the amount of hardware that's coming in just growing exponentially. And so as that grows exponentially, so does the opportunities for somebody to get their way in. That grows. And so you have to figure out how do you stop this. So let's look at Microsoft during the pandemic. They detected 8 trillion daily potential threats. Daily, 8 trillion. And that's just on the Microsoft cloud and their data sets. That's not including Meta, that's not including Google or anything like that. I mean, look at that number, right? 8 trillion and 560,000 new malware detected daily. How many people do you think you would have to put on there in order to manage that? A marching army. And again, each person is now a potential leak point too, right? So the more you put in there, the more you're torpedoing the reason why you're putting these people on here, okay? So we have to look at what is this blend of automation tools, right? Some of these tools right now can detect these things in fractions of a second, much faster than you can. You can't even push a button faster than that, right? And there's 1 billion malware programs now. And it's increasing every year. It increases as more systems come online, as utility companies start to realize and they start to get into, you know, the IoT, and they start to remotely monitor all that, more ways, more malware is coming online. So one of the biggest things these companies and people have to look at is, you know, how do we improve our productivity while also mitigating all these risks that we're just talking about? And a lot of their leadership is going to look at staffing, financial constraints. What is my return on investment? And this is where they need to sit down and look at that risk to return ratio, right? Are they willing to have a serious data breach just because they want to save $1 million? Is it worth it to them, right? And those are the kind of decisions they're going to make. One of the largest challenges as you get more of this stuff, like we said before, you become less protected in a way. You may have the data to make decisions, but it opens up more additional ways for you to get hacked, right? So you have to look at that balance between the two. And one of the big things, and it's not just in cybersecurity, but in the manufacturing world, in the military world, is resiliency. You look at that term resiliency, it's probably just, I would say probably in the last 7 years has resiliency really come to the forefront. Because here in the US, a lot of people are starting to realize that you don't have carte blanche to do whatever you want anymore. A lot of different countries, a lot of different companies are catching up very, very quickly and fast, right? Faster than when it was done here, because you had to learn everything from here, so it takes a lot longer. You take the automotive industry here, it took many, many years. Japan took less, Korea took less, China's even less, because they're building upon what everybody else is doing. And so now companies and the government here are starting to realize is that everybody is getting smarter, faster, quicker, especially with technology. So then they have to look at how can their company, how can their software maintain this resilience where if you're continually hit, how can you stop them? How can you stop them? How can you get back on your feet and prevent the next one and continue sustain of that cycle? So what is required for this resiliency? Number one, it requires dedication. It requires real dedication to this particular subject here is resiliency. Is that maintaining? A lot of companies and a lot of governments, they love to get the shiny new toy in, but they don't maintain it, right? And so you don't put enough money into it. You don't put enough authority behind it. And so it falls to the wayside. And so what happens is it may stop something for a little while, but if you don't maintain it, it will continually evolve, get smart, and that system no longer works. So you have to have this resiliency. You have to be prepared. You want to be adaptable. No one response is going to be the same as the next one, right? They will get smarter. If they can't get in this way, they're going to find another way, right? For those who have kids, you got that. No, don't eat that. Well, they're going to climb on there. They're going to wait for you to be gone. They're going to find some other way to get to something that you told them not to do. I'm learning a lot of this with the kids, you know. But this is where you have to be adaptable. You have to prepare for whatever comes your way from these kids, because they're smart, right? And what is your response and recovery once they get it, right? Come up with a new plan. I'm going to put it even higher so they can't get it, right? Get it out of the house, whatever it is. You got to be smart about this. You have to. This has to be part of your plan. There's also redundancy, crisis management, training, and the continuous improvement. Right? All of these things that we do here, that you're seeing here, is no different than what you do in your everyday life, in your career. If you want to be better, you want to move up in the ranks, you want to learn, you have to do all these kind of things. Right? It's not anything new. You just have to look at it from a different perspective. Right? So we've talked a lot about all the different ways that our data runs. And you see all of this down here, connected real-time data. And this is just top line. I mean, there's a lot of information down here that's feeding, you know, your Wi-Fi servers, your computers, the factory or your office itself, your servers, your emails, you know, there's a lot of data behind that's feeding all into that. And that's going into your in-house, right? It's looking at the integrity of your data. It has to maintain the integrity of your data. It needs to be that single source of truth. Otherwise, you won't know whether or not somebody hacked you, took your data and replaced it with something else, right? So your system's going to have to be smart. Now, what we're starting to learn is that how do you work with third-party systems? Okay. Traditionally, we have been, okay, we have our factory, we have our office, we have our server, everything is maintained in-house because we never had that third-party server before. So it was very easy to maintain physical containment of your information, and you had your own IT people to maintain it. Now you have a third party. Now this linkage right here, how does that third party get data back and forth to your in-house and back to you? You don't necessarily control so much about the third party. They have their own processes, they have their own security protocols, and now very hard for aerospace and defense and also other industries to really relinquish some of that control. Right? Most of the companies in the aerospace world deal in defense, and so there's a lot of requirements on them from either the classified world, proprietary world, that they're very sensitive of how they do certain things. But the thing that's helping this third party is the government and or the customers are starting to realize that third party is actually faster and quicker and actually potentially cheaper for them because they don't have a blank check now to write to any program that they want. So they're getting smart, like, okay, we're open to the idea of third party, potentially if it saves my program money, right? Because what's happening is you take Amazon Web Services or Microsoft's Azure or you know any of these other third party companies. For your company, you would have to build your own system. You'd have to build your own people. You have to build your own processes to just maintain yours. Okay, there's a lot of maintenance costs behind that. Is that worth it? And that's what leadership needs to look at. And customers starting to look at that too. So when you have the customer being open to it, now you have the opportunity to look at a potential area to save costs by offloading some of that work. Now, granted, in the aerospace world, you cannot do that 100% because there are classified areas that has a physical break that doesn't connect to the outside world. Those areas you still need to maintain in-house, but other programs, other data outside in your factory could be managed by a third party. You might have a hybrid system. There's many different ways to do it, right? And so that's what we have to look at here is, all this real-time information that's coming, we have to make sure we maintain the data and make sure that we have this analyzation part. Otherwise, this data is just worthless jumble if you don't analyze it and utilize it for something good to make yourself more efficient and better. So what does industry need to do? A lot of the industries that's not in the tech world, meaning like aerospace, medical, retail, and so on and so forth, a lot of them do not have a clear strategy of what they want. They'll come in and they'll say, hey, I need some kind of system to do this. But they haven't really thought it through all the way through, such as what is it supposed to do? How much of it do you need? How do you maintain it? What does that maintenance look like, right? And what is the end goal? Whether you're trying to be more efficient, you're trying to prevent hacks into your system, what is your main goal? And you have to come up with this strategy. If you do not come up with this strategy, You may win the first round of arguments with your executive and leadership team, but you will never win the next round. Okay? You need to have a complete, clear strategy, because one executive does not manage the next organization that you need on board, and so on and so forth. Which is why when you look at these commitments from a leadership perspective, everybody must be on board. There must be a top-down approach. It cannot be a bottom-up. From a bottom-up approach, you have people in the first line that does not have the authority, does not have the clout to be able to change something that's big. It must be a top-down approach, right? I'll give you an example. When I was building this factory, the factory itself was a fantastic top-down approach, which was very easy for me. But moving the labs over and creating new technologies in there, like digital signage, augmented virtual reality systems, and so on and so forth, was a bottom-up approach, right? Because they didn't see that yet as something that they need. And so I spent half my time in the marketing world. So as an engineer, I learned marketing. How do I get the executives on board? How do I get the managers on board? How do I get the technicians on board? How do I get janitors on board? They were even fighting me left and right, right? So we have to be very, very committed in what our strategy is going to be going forward, right? Just like anything that you do, if your strategy and your leadership is all over the place, you will not have a singular focus, and you will be all over the place. And it will be canned in less than a year. But when we have all of that, that doesn't mean we let it go. We must have some fostering of this innovation. Right? We have the system now, great. It solves our first problem that we have. It's not going to be the last one. And if you think it's going to be the last one, there's no point in having this system. It solved your first problem, you spend a lot of money on it, it cannot solve the next one. You have to be able to let your people innovate in the system, evolve it so that it can keep up to the times of what's going on. And once you have all of this, you have to be able to use it. Like I talked about earlier, a lot of companies, a lot of executives, we have all this information, it's in our network, it's in our servers. When I was doing proposals, they used to tell us, don't worry, it's all in the server. Right. So I go in the server, I would spend hours upon hours sifting through the server to try to find the information that I need. And so one of the use cases that I pitched to them was from a optimizing the process standpoint, what if you took all that data, you took the knowledge from all your senior people, from all different kinds of programs, large, small, built in-house, hybrid ones that you work with companies, partner with companies on, and you took all that information and you're able to have your proposal team plug in everything that's required, whether it's a Class A satellite, Class B satellite, whatever it is. It needs to be in this orbit, it needs to weigh this much. It takes everything that this company has ever done and it spits out a framework for you 70% there. It's not unheard of to do that, right? Do you know how much time you can turn around a proposal much faster? Our proposal world works only as fast and as good as the person that's sitting there representing that particular organization. And I give you an example on that too. We were looking at a similar program that I worked on before, and the people that worked with me was one who's leading the proposal. So other people had never worked on that program or something similar. They came up, presented what they were going to do, they got crucified. Every single one of them got annihilated. Why are you doing this? Why are you doing that? I don't know you. I don't trust you, right? You got to give me more information, so on and so forth. So I go up there. I presented what I wanted to show them. The guy was like, oh, okay, because he knows. We worked together. He understood what I was saying. Looked at the program manager. Looks good. You trust him? Yeah, we worked together. Done. 5 minutes. Okay. Everybody went hours and hours and days reiteration. So if you're confident in the data that you have because it's knowledge from everybody else, you can spit out a framework and you can get yourself a lot faster, right? And you have to be agile. I know that term has been out a long time, being agile and adaptive, but it really is true. A lot of the aerospace world and even big industries like the medical is probably one of the big ones too, where they're not agile. They don't want to move anywhere. They're fine with what they have because it works, right? And so what happens, I'll give you some examples in the medical world, is they sit there, and people might experience this, is we're shortage of nurses. We always have a shortage of nurses. We don't have enough nurses. And so based on my experience with the medical world, you know where all the nurses are? A lot of them are in administration work. Why? Because it's a required job. It's a required thing for them to be a nurse degree in administration work. Even though the certifications that they need to be a nurse has nothing to do with their job title or anything that they're doing. So what did you do? You create jobs that require this particular skill set, which the skill sets that they're certified for has nothing to do with. So what you're doing is you're pulling all these people out, and you're dumping them here, and then you're saying you're short of people. Okay, that's the same thing in the engineering world. I need engineers to do PowerPoint, so I'm short of engineers. Well, get somebody else to do the PowerPoint, reallocate your resources, be smart about what you have, and put them in. Or, like I said, you have to look at everything from a larger perspective of, am I allocating my resources smartly? And it's not just finance. It's people. It's knowledge, right? It's hardware. It's software. Everything when we talk about resources, that's how we have to look at it, right? Everything is a resource inside the company to help a product get delivered. And we have to be very smart, is collaborate and form partnerships. I'm in the belief of, I don't want to recreate the wheel if I don't have to. It isn't necessary. Engineering companies, engineers, nothing on them, but we love to build stuff. If I know it, I'll try it, I'll build it, even though somebody else already has a product that's 90% there. So we spend time, we spend money, we pull that person out. They don't have all the correct infrastructure or support needed to build it, but they can do it. And so what they'll do is they'll come up with something that solves the problem. Now somebody has to maintain this. Who's going to maintain it? Right? Again, when you develop this partnership, that company you develop the partnership, that is their forte. You are paying them, but you're paying them for the maintenance and continued support. I'll give you another example. We developed the software in-house, and we're using Oracle Forms. And this software has been around for a long, long time. We did not want another company like Oracle or whoever to maintain it for us. We did it, we built it ourselves, and we used it. 2015, I want to say, we had to upgrade because Oracle's like, hey, we no longer support this version that you have. We have Oracle 5, okay? I mean, we're talking a decade behind because that's not our forte. We don't look at it until it breaks, right? We don't maintain the system to be smart and be adaptive as we go. And so what happens? I get pulled in as an engineer, mechanical engineer, by the way, to lead a software initiative. So take that one, for example, okay? I get pulled, not my forte, to lead a software initiative. Granted, I've got great software people, but they were not from our partners, Oracle. Our people made a kind of a stopgap measure to figure out a way to upgrade us to the newest version of Oracle. That's all their mandate was. And so in 5 years, we'll have the same problem again. We're going to have this continuous problem if we don't collaborate and form these partnerships. with these companies. And we have to invest in these skills. If we don't have the correct people in there, you're going to put people who may do the job but not efficient. Okay. For example, when I got pulled in to run a software initiative, granted I had some software background working with the Navy, but that's not my forte. So it took me a little bit to learn. Granted, I brought in some fantastic software people who knows how to do this, and so they were my left and right hand people to help me along the way. I managed the whole project, right? But if we don't invest in this skills development, you people won't know how to use this kind of technology. I'll give you another example too. And this is kind of a backward system, but at Northrop we still use pagers, and that's just due to the fact that we're in closed side, right? So it's just one way. It's not a two-way system. And I had a new engineer come on board, and so she was looking for this one person to answer a question. I go page that person. She sat there looking at me with a blank stare. I'm like, don't know how to page, do you? She goes, nope, have no idea. Now, it's kind of a backward, but that's the whole point, right? You bring somebody in, they don't understand these systems, they don't know how to use it, it's worthless to you. I used to have an engineer that's been there forever, and he refused to ever use a computer. So for almost 12 years, he used an admin to convert his written procedures into Word. We had to provide an admin to him. It was two people doing the same job. Refused to use the computer. Didn't know how to use it. So we have to be smart about investing in our digital skills. And as you can see, these last 2 pages, when you look at everything, it's one whole encompassing from beginning to end. If you're ever going to use this digital transformation, you have to be smart about what you want to use it for. You have to make sure that the leadership and everybody below understands what you're going to use it for and are on board with it. Then you have to make sure that you can maintain the system. You have to be smart about any kind of changes along the way, because changes will happen, right? Changes in whether it's geopolitical, changes in technology, changes in just people culture in general. You have to be adaptive to that and have to realize it will come, and you have to figure out how to change with it. Be smart with your resources, like we talked about. It's only finite, right? So be smart of how you use your resources and work with the people. I get it. We're all technical people. We can do everything ourselves, but it's not necessary to do everything ourselves, right? Sometimes things are very time sensitive. So you want to bring in the expert so that you can get your product out faster than somebody else, right? So be smart about that. And then, just like everybody else here who's here to listen to my talk, you're investing in your own digital skill development. And so am I, as I talk to all of you afterwards, right? I'm learning from you as well. Different areas you worked in, what is your perspective? I'm learning from you as well. So we have to be very smart about all of this skills development. And thank you for your time. That was the end of my presentation. Is there any questions? Still absorbing all the info?
It's all big data.
Yeah.
Dennis, what is it about IAAA that you find is a good forum for presenting these kinds of overviews?
AIAA, the way I look at it is that there's a lot of people on here who has a lot of curiosity, has a lot of interest, has a lot of ambition to do more and to help out more. And so I find this forum as a very good place to meet people such as yourselves, and things that we can collaborate on, things that I can help you with. as well, or vice versa. So this is a very open environment to that. And so that's why I like these kind of forums. If you work with other areas, like if you work in a medical industry, they're not necessarily as open to it because they are very, like I said, siloed in their own area. So they don't necessarily have most of their conferences and most of their information and most of the things that they work with is medical based, right? We are technology, so we're more open to all of this kind of stuff, right? Even though industry like the medical world, they need it as well, but they're more concentrated on, hey, from a medicine perspective versus how can this stuff help them? So it's much easier to talk here and potentially branch out from there and help others.
AC online, raise hand. AC, go ahead.
Oh, okay. Thank you. Yeah, I had a couple of points that I wanted to sort of maybe have you address.
Sure.
One of them, for example, is all these systems basically require one component, and that's interconnectivity. And so the systems for I guess earthbound or even near Earth type applications, we have fiber optics, we have radio communications, and so forth. I know earlier you were speaking of the use perhaps in lunar outposts and so forth. And so connectivity to, say, earthbound systems require communications. And so regarding that, there would be a situation where you have some type of time delay. So to the moon, it might not be too significant, maybe a second or two. But then if you start thinking of the future and you start thinking of, say, maybe Mars applications, you run into situations where you have up to maybe half an hour delays between communications due to the speed of light constraints. So there might be a need for duplicating these systems at the site that they're required, which brings up another point. Some of these systems, at least in current configurations, require huge amounts of computing power. Some of these data centers are for AWS, for Google, and so forth, are huge distributed data centers that require tremendous amounts of power. For example, I read somewhere that ChatGPT, currently as it's being deployed, requires something like 300 megawatts per day of power to run. So that's a huge amount of energy requirements for all these systems. And as they expand, you can only see increased demands for electrical power to run these systems. So these are probably maybe more future sort of concerns, but I was just wondering how you might address some of these points.
So the first point that you have in terms of having a duplication of systems, we do that now in the space world. The example being is when we go to the launch site operations, some places duplicate their data sets from here to there, and then we have a interconnective tunnel back to provide information. And so you're right, being able to have the data there allows you to make faster real-time decisions. The things that we have to look at from a duplicate data system is when they connect to each other again, you have to find out what's that single source of truth, right? Because this system might have more information than the other. So when they connect back again, who has the right truth, right? So you got to make sure that every time you connect, you got to make sure you're connected correctly and you have the correct kind of data, right? To prevent any kind of issues going on. For the others, you're right. It does. A lot of our hardware right now requires a lot of power, and the way that our systems are written. I don't know how the software is written and like what it runs on in the background, but from my perspective, as we get more and more technologically advanced, the systems will get smaller, faster, and more energy efficient. The software, the coding that's written behind it becomes more efficient and faster, and therefore it's going to require less computing power. And we see that in our everyday lives, right? the applications you have on your phone, the apps that you have on your computer, right? For those who used to do digital or movie making and stuff like that, I mean, you used to have the top of the line $10,000 computer in order to crunch some of the software, right? Now, any laptop you buy can do it because it's optimized and designed for it now, right? And so I think right now, you're right, it requires a lot of power, but this is a nascent software. And so as we get further down the line, it will get better and more efficient and optimized, so it will use less power. Okay. Anything else?
It's a good example of that is commercial Bitcoin miners, which are optimized with ASICs.
Yes.
That it's orders of magnitude more efficient.
Correct. Yes, that's a very good example. That's correct.
But then you lose the adaptability because you have to make a new chip.
Yes.
To change the goal.
Yeah. So that's where, you know, depending on what your goal is,
yeah,
right, you can make that decision on what you want to do. Like a lot of these softwares, they realize that no one, if they want their software to be used more prevalent in industry or just consumer perspective, you cannot put a requirement on there that everybody has to buy a $10,000 top of the line computer. So then they went back and they start to realize, okay, how do we optimize? How do we cut off things that maybe they don't need right now? How do we put it on the web? I mean, on the cloud, so that it's computing in our servers and not on, you know, your hardware itself, to help break up some of that computing power. So there's different ways of how you solve this. And that's what a lot of these software companies have looked at is, you know, hey, like you take Microsoft, just their suite of tools, right? Word and PowerPoint and stuff like that. It's all on the web now. Before you used to have to download it on your computer and all this kind of stuff. So a lot of the computing, upgrading, processing power, it's all done on their servers. And it's probably easier for them to do that, right? And of course they make more money now you're on a subscription service, but.
Dennis, I think there's a gentleman from JSC raised a hand, but there's a Q&A. If you want to, this gentleman probably doesn't have mic access.
How does digital transformation affect the scalability of production, for example, 100 to 200 units or 100 to 1,000 units? And how much benefit is achievable? Okay. Digital transformation is a overarching term that covers everything. So let's take, for example, if you're building one specific product and you're going from like 100 to 1,000. The way I would look at it first is you got to look at how your production facility is run. Is it manual? Is it, you know, you're constantly stopping because you need meetings, because things are old? I don't know, right? There's so many things that come into it. But what you can do is, for example, highly repetitive parts can be done with a robotic system. Just think about it. Let's take an example. Let's take Tesla gigafactories, highly robotic, versus regular companies like GM and Ford, which are more of a hybrid system. They're almost like half robotics and half humans, right? And why do they do that? Robotics can create more because you can run 24/7, depending on what your product is, right? Here, if you have a human factor in there and you have high production, you look at, oh, well, I can only do 8-9 hours before I have to start paying overtime, or, you know, they time out because we overwork them. And I can only do 3 shifts, and there's a lot of issues that come on board. So depending on what your product is and how fast of a rate is and how you're building this part, there's many different ways that you can scale up using, you know, digital automation, right? For example, if you're building a part and you want to iterate it quickly and fast and get information from your customers, having people give you feedback. For example, let's look at the real world today. Now you can go onto the website and you can give feedback and comments immediately on your social media. Imagine if they had to email you via the post office. or I'm not email, send you a letter via the post office. You open it, wait, co-locate it, think about it, formulate your response, and send it back. Weeks, right? So now they send you information. Hey, I would like to see this on your next video. Boom, next video in a day. Here's what you wanted, right? Many different ways that you can use digital transformation to help your production scalability. It all depends on what you're looking for, what you're building, and how it's being built. I think that's the second question. Why are there such weak security standards for IoT devices? So that's a very good point, and that's been talked about quite a bit. Most people, when they built these IoT devices, never thought about the interconnectivity that it could have in the future. From a cost perspective and from a consumer perspective. Consumer perspective, the very first thing isn't to think about, oh, how much security can I get from this? Right? Oh, great, it can do this for me, fantastic. But now that it's connected to your Wi-Fi, your computer is connected to the Wi-Fi, right? And so now it's got an inroad in. So people don't think about the overall arching system of what these IoT devices are meant for. Now, you take it from an aerospace perspective, that's a big reason. I've worked many, many years in the classified world, so every person, every piece of hardware, every electronic, you know, I've been so ingrained to just look at it like, should it even be in my pocket? I'll give you an example. When I left the classified programs, if I walk into a building with my phone in my pocket, I feel like I did something wrong. I have to report myself. That's how ingrained it is. In any piece of electronic on you, walk into a building, I feel like I did something wrong. Okay. And so in different industries, the security is much higher, so then they realize it. So any new piece of technology that comes in, like when I built the new factory, one side was classified world, one side was open world. And I wanted to put Wi-Fi connectivity throughout. So what happened? First thing that came in, how strong is that Wi-Fi? What kind of signal is it? Where is it going to be placed? It cannot be within so many feet of that wall. That wall needs to have double shielding and so on and so forth. And it just goes on and on and on because that is their world. And so they realize it, right? Outside in the consumer world, nah, they don't care. Great, I can open my door with just that. Who cares about security? Otherwise, the only thing they care about is as long as somebody doesn't know the code, right? But can it be hacked easily? Sure, it can be hacked easily. Now people are starting to look at, oh, since we're so interconnected now, you can worm your way in through to the least connected part of your system and to get into the most protected part of your system, right? And that's one of the reasons, like in the aerospace world, they don't want so much technology because they realize a lot of that technology on an open world, they don't have that world, that security view where everybody inside this secure world is paranoid, right? They do it that way so that you become paranoid, right? And so people on the outside, it's fine, you know. I hide my key under the doormat. It's cool. It's me, on the other hand, nah, I can't do that. Something might happen. And so if you live in that world, you start to think that way, right? So in the consumer world, people don't think that way. Some companies do to protect your data. Like, have you noticed all these big companies have all these data breaches? But these companies that have the data breaches are more consumer companies like the Metas and the Googles of the world. Yes, they realize security, but your security and your data that you lose, not a big deal to them. Okay? Now, have you ever heard of Amazon Web Services that's meant for the government having a data breach? Probably don't. Why? Because they hire the best, they hire people with security clearances, and they make sure that those systems are ironclad. Because the government requires it, the industry requires it, consumer stuff, not so much, right? I think those are only two questions.
Yeah. Dr. Silva Martinez, I saw you raise hand earlier. You're welcome to speak up. Anyone online? You have the mic access. Do you want to ask some question? Mark, I know you are very interested in this topic. Do you want to say something? Go ahead, Mark. Oh, let's see.
Oops.
Mark, I saw you raise hand. Go ahead.
Okay.
Hey,
Can you
how
hear
are
me
you?
now?
Yeah.
Yes.
Okay, I'm still picking my jaw up off the ground from when you said you were a mechanical engineer. I'm blown away. You have all this knowledge on computers and data systems. And I really enjoyed the part where you said, you know, where left hand doesn't talk to the right in some of these big companies, because, yeah, I experienced that firsthand many times.
Right.
But a very fascinating presentation. And yeah, my wife is not feeling well. She'd be asking you 10 cybersecurity questions right now if she were here.
I'm sure. Well, you know where to find me, so you can always email me.
Okay.
I mean, it's just a matter of I've done so many different kinds of projects, and you know, working in the space world, you work with software people right next to you. You know, years of managing programs and projects. Everything you get a bit of knowledge of everything, right? Which is one of the great things of working in this industry.
Agreed. Yeah, I learned more electronics and built more prototype circuit boards than I ever thought I'd ever imagine doing.
Exactly right. Right. Good question.
What was the hardest part about building that smart factory?
The hardest part was if you go back to like on my last two slides, it's going to be there we go. It's going to be this one. It's your leadership commitment. Because the factory that I was building was meant for multiple programs, so there's multiple executives involved. There's certain reasons why we did it, and so you don't have that top-down approach. Each executive will, you know, go amongst themselves, and you're kind of stuck in the middle because you don't have enough authority to override them, and nobody on top is going to separate it for you, right? And so you have to work with them the best way you can to kind of keep this system moving forward. So that, I mean, was my job as the project manager for that, a program manager for that. But that was probably the hardest job, is to keep the enthusiasm going, to keep the commitment going, and to keep everything together and not just get spread out. You know, people like to go on tangents. So kind of keeping it all together. I think that was probably the hardest part of that, is the leadership commitment. I mean, you might have some commitment up at the top saying, yes, this is great, this is what we need to do, doesn't get flowed down. So then the lower level leadership, you know, they'll just do what they kind of want to do for their own, you know, benefit. I'll give you another story here is, after I left, there was an overrun on the project for the second phase of it, and they decided to do something different. So they were called up with our president, and I heard this secondhand, and they asked him, what's going on? Why are you doing this? So one of the executives said, well, I need to buy down my risk. My risk. This is multiple programs. And his boss told him, that's what I pay you for, is to manage your risk. And everybody be quiet after that. Went back to original plan. Okay? That's where they realized that this person up here knows what we're doing. We know what we're doing. Everything in the middle, you know, it's a toss-up. That's the difficulty. That's why I say you need a top-down approach, not a bottom-up. Bottom-up, you would take more of your development and technical time to manage the political aspects and the, kind of ego soothing jobs, then you need to do. Any other questions?
I was wondering, how does an entrepreneur fit into this? I guess this slide is about how industries need to define their strategy and what they need to do. How does like an entrepreneur go and get the stakeholders aligned and get things moving?
So from an entrepreneurial standpoint, you have to understand the industry and you have to understand what their pain points are, right? And of course, with most leadership, right, it's return on investment. Number one is return on investment, and number two is how does this make them look in their customer's eyes and perspective and the boss's eyes and perspective. And so once you realize those two things that they want, then the next thing you're going to have to do is you're going to have to come up with some kind of product, right, to show them some kind of prototype. And it's got to be a working prototype with their use case, right? Their specific use cases. Otherwise, if you're making them try to imagine what their use case is to your prototype, won't happen. They won't take the time to do it, right? Which is why, if you ever pitch in front of executive, you got to be concise, to the point, less than 5 minutes. Issue, what the problem is, how you plan to solve the problem, how much is it going to cost, and what's the maintenance for it. You got to solve it. And so from entrepreneurial standpoint, you got to understand what the issues are, have a prototype that solves it, and then you have to get to a lot of these trade shows, like the Space Generation Advisory Council. Let's just say you're doing something for space. Huge event up in Colorado every year. Lots of executives, lots of customers, lots of military people. That's where you can showcase your product, right? That's how you start to meet these people. You go to other events, like there's one in Florida that I'm going to be going to, where a lot of government personnel is going to be there. And that's how you show them what your product is. Unless you get actively sought out, like when I was doing the technology, I actively had to go search out for certain companies that met what I needed to do, because some of those companies, startups, didn't really look at the aerospace industry or whatever industry you're in, because it's not their market that they're searching for. So I have to actively go out and go find them, right? Bring them down and talk to them as, hey, this could be a new market for you. So there's many different ways that you can meet these kind of people as an entrepreneur. So I think you have a lot more opportunities now than you probably would have decades ago, and they're a lot more receptive to these things, especially in this day and time of budget constraints. You have near peers now, from other countries, so they're more open to listening to ideas of how to maintain their superiority, right, in terms of a military standpoint. And so this is a very good time for entrepreneurs to be able to pitch their ideas, and you'll get a lot more interest than you would, I would say, 10, 15 years ago, right, when these current near peers are nowhere even close. And so they wouldn't have worried about it.
Sorry, when you say near peers, I've never heard of that before.
So that means like other countries that are catching up.
Got it.
Right?
Okay.
And so 10, 15 years ago, no one could catch up to the US, right? That's what they thought. And so they quietly did their thing, and so now they're close, not there, but enough to make the leadership here rethink how they run the government, how they procure things, which is why NGAD came around, right? 2 years to turn around the next generation fighter plane, because if anything were to happen, they need to crank these out quick. next generation quick. Same thing with satellites, which is why they are going to smaller sats versus large monumental satellites, because these smaller ones are quick to get up, quick to build, resiliency quick to replace if they were ever damaged, right? And so their whole point is, you can shoot them down, but I'll throw up more than you can shoot down, right? And so that's part of the resiliency bonus.
Thanks.
Yeah.
Two more questions, Q&A.
Do you envision the development of AI systems to monitor other AI systems? How do you use AI without getting into places that you don't want to go? When you use AI tools, do you think that they should run in a sandbox? Okay, so let's take the first one. Do you think development AI systems to monitor other AI systems? That depends on how smart those systems are, right? If you have two equal systems, you can theoretically have them monitor each other, but you have to look at why you're doing it, right? Why are you having one AI system monitor another AI system? Is it the checks and balance? If it's a checks and balance kind of a system, you know, what industry is it used for? So there's many different ways to use this. You probably don't want to use an AI system to monitor another AI system. If you're going to do something like that, you're going to have a hybrid AI system with a human to monitor the AI system, potentially, right? So that's kind of my perspective on that. How do you use AI without it getting into places that you don't want it to go? That's a problem that we have right now. Let's just take the government, for example. You know, their quick and easiest is complete physical firewall. Nothing goes outside this building, complete cut, right? We have no data line outside this building. Everything that comes in is manually carried in, scanned, so on and so forth, whatnot, right? The AI system that you develop or somebody else develops to find holes in terms of a cybersecurity kind of a breach, that's going to be one of those adaptive systems and agile systems that you have to be smart about. You have to realize that your system has to change with the knowledge that people knows and different ways that they're going to get in. Because currently, right now, everybody understands the physical aspect. How do I lock down a building? How do I lock down a facility? You know, how do I lock down a house? But it's a little bit harder when it comes to electronic systems, right? Before it was Wi-Fi, oh, no problem, Wi-Fi. And now everything's connected to Wi-Fi. Now there's another entry point, right? So we have to be very judicial about what we use and how those systems are connected so that we can maintain the security, so that AI systems don't inadvertently or purposely get into those systems that you don't want. And it is part of the higher part of cybersecurity of maintaining, you know, your data integrity. What does it mean? What is an evolved AI system 10 years from now, right? But you have to be that person to realize that it will not be the same as today. And if you realize that, then you can be adaptive to that, right? If you think that the current technology today is going to be the same in 10 years, you know, you've already failed. Especially if you look at the way every industry has changed in less than 5 years, right? So exponentially, things will change as we get smarter and smarter technologically. When you use AI tools, do you think they should be run in a sandbox? Absolutely. So from a software testing perspective, I mean, generally you want to run most things in a sandbox before you actually release it out as a final product. You want to do all your testing in there and so on and so forth. So yes, you probably want to run your system in a sandbox prior to release. Running your system in a sandbox after you release it, I'm not quite sure the purpose of that. But then again, I'm not a 100% software person, so if anybody else knows, you do let me know. Let's see, listen. Is Google using AI in its search engines? Yes, it is. If you look at some of the commercials that they put out, now they're telling you that they're using AI in their search engines to help you, right? Such as you put a picture on there, oh, what is it? It will do pattern recognition and tell you, oh, it's this type of animal or this, you know, this area or whatnot. So yes, they are starting to incorporate AI into their search engines, and you'll see it. They're actively advertising that. That's one of their features right now. Is there any other questions?
Any question, folks online? I think there's some chat. Take a look. I think AC said something, but that could be earlier. Oh, this is just.
Oh, yeah. I don't think there's any questions there.
Okay.
Okay.
Yeah. Well, you are welcome to stay after the Q&A and network. So let's thank the speaker again. This is really wonderful, and on behalf of the LA Las Vegas section, we thank Dennis for this great presentation.
All right, thank you.
Thank you.
Thank you very much. Thank you all for coming.
Thank
Listen
you.
to me talk.
So we'll stop the recording.